Welcome to SimHBA, the Simulated Human Behavioural Audiometry software. In this tutorial, we're going to learn how to use SimHBA, so let's get started. Here's SimHBA. We'll walk you through some of the basic features that SimHBA has to offer. In here we have an open mode, which is for training purposes, where all the features are unlocked and that the user can see all the information about the case. Then there's an assignment 1, where the true case information is hidden. You can unlock that in assignment mode if you have an instructor version, and you click on the instructor view on. Next to that, we have our tympanometry, which we can perform tympanometry, acoustic reflexes, and DPOAEs. And we'll show that in a moment. There is a random infant case generator that will be offered in future versions when we're implementing visual reinforcement audiometry. But for now, we can randomly generate an adult case by clicking on that button. Instructor view on and off, already mentioned. We can load cases, save cases, set this auto save rate so we don't lose our hard work. Patient-centric view is really for our evoked response audiometry software called SimHBA, so Simulated Human Evoked Response Audiometry. If you want more information, you can check out the website here. If you would like to have the font size larger on your screen, here's a scaling size here, so we can just increase that to 1.5 and all the font becomes larger. If you want to revert it back, just go 1 divided by that same size and you'll revert back to the original scale. Underneath that, we have the patient information, the initials, age and months, case ID we can change to whatever we like, so when you save it, you can keep track of your cases. This is genetic sex, female, male, test date, and birth date. There are multiple tabs just underneath that: simulate case, case report, behavioral testing, and evoked response audiometry. In the simulate case, this is where you would simulate your case. You can do it randomly by selecting any of these buttons for typical hearing types, conductive hearing loss, sensory neural hearing loss, auditory neuropathy spectrum disorder, and retrocochlear. The true thresholds are represented underneath for air conducted, left ear, bone conducted, left ear, right ear, ANSD %, and retrocochlear %. There's also a pure tone average of the 500, 1000, and 2000 hertz thresholds presented here on the right. So we can select them randomly, or we can change these things manually. So we can make that 0, and it automatically adjusts the audiogram as you see over here on the right. Underneath the true thresholds, we have the psychometrics. This is the response probability relative to sensation level. So this is looking at behavioral reliability. If we put this to be very high, that means that the response will be detected in a very tight or narrow region of sensation level, so highly reliable, or we can make this patient very unreliable. So they're responding haphazardly, almost between -20 to even 60 dB, and never ever reaching 100% probability. We'll change this back up to something that's more reasonable, plus or minus 10. To the right of that, we can also adjust for differences in attention across session, also physiological noise, swallowing, moving neck, fidgeting, those kind of things that will change the threshold from presentation to presentation of the stimulus. So this is the standard deviation in dBSL for presentation to presentation. We can allow that to fluctuate across the session, and in this case the session is 2 hours, 120 minutes, and we can change it to be fluctuating quite a bit with a large standard deviation, or very little to nothing. We can also make this stable across the session, so it always has the same variability. Okay, we're going to jump over case report and we're going to go into the behavioral testing panel where we have our patient already set up in the booth for insert earphones. We can change that to superaurals, bone conductor on the left, and bone conductor on the right. Now the patient will respond by raising their hand when we present a stimuli, and when they do that, we can see their function response happening on the psychometric curve, and when their sensation level, shown here by a red circle, is above the chance line, it gets you a green dot and they will raise their hand. Underneath the booth, we have the audiometer, similarly set up in a format to other clinical audiometers. We have a stimulus playback, and note when we're playing back the stimuli, please make sure that the stimulus level output of your own headphones, if you're wearing headphones or your speakers, are at a comfortable listening level and do not exceed safety limits because we want to protect our own hearing. We can set the maximum output of those speakers relative to the patient's, what the patient hears, by setting this at a specific level. Usually 60 or 80 dB is pretty good. When you're presenting the stimuli and you're listening to them, if it's the tones that you present out. But when we're doing live recordings, the speech recordings, it's what the patient will likely hear. And this is modeled off of the auditory filters that are set up based on modeling of the hearing system from Glassberg and Moore's research and others. So we can present different stimuli. We can do tone stimuli. We can do pure tones, which I'll demonstrate here for 1000 Hertz. I'm going to turn down the stimuli a bit. So here's where you adjust the stimulus intensity. And this 1000 Hertz. Click and press the button. You can hear the tone come out. Now this clicking and pressing is just like the audiometer. It presents for the amount of time that you've held it down. The thresholds are adjusted for temporal integration. So if you press this for a very brief period of time, the thresholds are going to be higher. If you present it for 1 to 1.5 seconds, the thresholds are going to be lower. We can also make this a warble tone. We can present live recorded speech to determine the speech detection thresholds. So let's go give this a try. We're going to use an example of baseball here and a recording of a live baseball. And the patient detected that. And you can see underneath there was the VU meter, which showed my speech going up to peak of 60 dB and fluctuating based on the phonemes there. We can also do speech recognition thresholds or word recognition scores. We can record that live. Let me just increase the stimulus intensity a bit, super threshold, so they'll be able to maybe respond back. Keep in mind that when you do this, that this is really only for fun. Your computer speech recognition systems are poor performers, and this is only offered in Windows 8 and 10 currently. Mac versions will come, so let's give it a try. Baseball. Baseball.
Baseball.
And she responds baseball. We can also do this using pre-recorded lists. So these lists are down here to the right where we can do spondies or new 6 other word lists. And you can also select your own word lists and call those in. So we'll just go ahead and keep on that same.
Baseball.
And she responds baseball. And again, you can raise or lower
Baseball.
the stimuli until detection.
Baseball.
Is really not heard.
Baleful.
And gets it incorrect. Okay, so that demonstrates the different stimulus types we can present to the patient. We will have future versions of narrowband noise, broadband noise, and maybe even external recorded information. We can put in masking, so this is masking to the right ear, so it does IPSI and contra depending on whether or not you're stimulating right or left. And you can increase and decrease the amount of masking in there. So let's give a demonstration of that. We'll do a broadband masking. Let's go 50 dB, and we'll just do a warble tone of 1000 at 50, and we'll present that just to give a demonstration. And the patient heard that, and you could hear the masking in the patient's left ear, which will be presented to you, the tester, in your right ear, because we're looking at this from a patient-centric viewpoint. And you could hear the warble tone in your left ear if you're wearing headphones, which is the patient's right ear. And we can change the frequency and the intensity, like I said. When we get threshold, let's say we do 8000 Hertz. Let's take off the masking here. and the patient didn't quite hear it, and let's say 80 was our threshold, we can go ahead and store that response, and it will automatically store the response over here on the right for the left ear audiogram. Now I'm just going to jump to case report quickly because that automatically updates in the case report. The audiograms we have for right and left, we also have the speech recognition thresholds, which you set, so we can change that to 55 dB. And if we did, again, automatically gets updated in the case report. So here's the speech audiometry at the very bottom, showing 55 dB, and it's recorded speech. Or we can change this to live, and it will change to live. We can set our word recognition scores. We can say that we used a different list, new -6 if we like. We can evaluate based on reliability, good, fair, and poor. And the other thing about this is that when you're in open mode, you can select true thresholds, and the true thresholds will show up as dotted lines, AC being the colored and BC being the black. If you're in the assignment mode, this button is not visible, enabled, so learners can't see the true thresholds. We added a start session button. Currently it's in session up here. We'll go ahead and click that off. It'll warn you whether or not you want to clear all the behavioral results. For this, we'll just say yes, that's going to clear everything. And then you can see it's a start session button. When everything's cleared, we go ahead. Now we're in session, like we've started a new patient, and we're going to go ahead and test. The other thing we've added here is a show test data. Go ahead and click that. It's the psychometric test data. So all the psychometric data that's being presented over here in the psychometric curve on the left, it will be presented in this table as well as presented as a graphic form as a trial by trial basis. So it's stimulus intensity in the same dB scale relative to what you see. So it's in the same frame as the audiogram, so -20 to 120, and the table will be updated. So let's take a look at how we do this. Let's present a relatively intense stimulus, tone, warble, 1000 Hertz. And the patient heard it, raised her hand, and you see 50 dB here. And the table, it's right ear, 1000 Hertz, which we presented. The stimulus duration was about 1500 milliseconds. The dB sensation level was 11.5. The response present was in the right ear, so that's a yes, but not from the left ear, so a no. The reaction time is 370 milliseconds. The intraoral attenuation for air conduction was 59 dB, and the intraoral attenuation for bone conduction was 5 dB. So we can go ahead and decrease the stimulus intensity. Patient heard that. And you can see that there was a no response right at threshold. So this red line here is the true air conducted threshold. The dotted red line is the true bone conducted threshold for the right ear. And here is the true bone conducted threshold for the left and air conduction for the left as well. If we put in masking, so let's put in some contralateral masking here, 45 dB, and we'll present this again. And you can see the shaded region here is showing masking. So if we were to decrease the stimulus intensity, and now we're showing masking of the left ear at the level of 45 dB. We can also put in ipsilateral masking too. And so you can see there is right ear masking here as well, and we're getting no responses. So this will be helpful for reviewing what the learners had presented to the patient when doing the testing, also for the learners themselves to understand the psychometric function and the psychometric methods that you are teaching them and how to perform those. Now we can also do this for speech recognition thresholds or word recognition thresholds. So we'll just go ahead and select on that, and we can see the chart disappeared here, and that's because we're now onto speech. We can select our words down here, let's say airplane. I'm going to turn off the broadband masking though, and we're going to present this at a super threshold level.
Airplane.
And we get the response airplane. and we can see that there is a colored asterisk that designates that there was a response that was correct. The word was airplane and the reply was airplane, and again DBSL, response from the right ear and not from the left. And we can lower
Elaine.
the stimulus intensity, and now we get an incorrect response here, shown by the black colored asterisk. And we can change our words.
Armchair.
That was a correct.
Baseball.
And we can continue to do that till we get no replies or incorrect responses. So this will track which word was presented. You can click on each one of these and it will update the table. So this was the correct baseball reply. This was the correct armchair reply. This was presented airplane, but the patient replied with Elaine. So when reviewing this in the assignments, the students won't be able to see this psychometric test data in the assignment mode, so this assignment 1 mode, but when you're in the instructor mode and you turn the viewing on, this will pop up. You'll be able to review what the learners had presented to the patient. We can go back to the tone and it'll automatically update what we had previously. To switch between different frequencies to find out how the learners performed their testing for each different frequency, we just select our frequency in our audiometer and it will update accordingly on the psychometric test data if the data is present there. So we can go back and we can see speech here. Let's move on to the case report. Case report, we can have history. We can add anything we want. Patient recently went to a outdoor rock concert. Add whatever you like, and you can save the case. The users or learners can also add and change this and then send that back to you. The behavioral audiogram is automatically updated based on the results that you are performing in the behavioral testing, as well as the speech audiometry down here. Here are the results for the Otoacoustic emission testing. So let's go and actually do that. So here's Otoacoustic emissions. What we can do is we've selected the tab, DPOEs, and let's go and perform a DPOE test. So the probe goes in, and then the test frequencies will be presented, and you'll see the DPOE here. Once the DPgram is generated, it will update this table down below for the different F2 frequencies, the DP, noise floor, signal to noise ratio, reliability, and whether the response was detected as abnormal, no response, or present. In this panel, we can also do tympanometry, which is just below. And let's perform a tymp. Right here, we can see the admittance, and that will automatically update in the case report as well. And we can also do that for the left. And a chart is to the right of that, and we can call this the different types that we want and then save that. We can also do acoustic reflexes, so click on that and we'll just demonstrate a right IPSI. So this is stimulation of right and IPSI right ear recording. This is automatically being done, so 85, 90, 95, and then 100 dB. And so then you can make your judgments of whether or not there was a reflex. Let's say we judge this to be 95. We could set that to 95 and it automatically gets updated there. But I actually believe there's a little one there at 90. So we have a reflex there at 90, automatically gets updated from what you present to this table into the case report. And we can select the different frequencies right here. This will also do contralateral recordings, so right ear stimulation, contra left recording, as well as right ear contra decay. So you can look at the decay functions and also that for the right and left. And underneath, what you can do here, this is the AR signal. What this shows is if we did do the testing, whether or not Like we thought that there was one here at 90, and yes, you can see in green line that their true response reflex was present. Let's close out of that and show you the rest of the case report. If you had the evoked response program, the SimHBA program, and did evoked response testing, you can add the results in here for their neurological as well as threshold testing. For SimHBA, we can update their summary of findings. The patient had type of loss, and the learners can also add in the recommendations. They can save the report as an image file and send that to the instructors. This summarizes some of the basic features in SimHBA. I hope you enjoyed watching the tutorial. Check out more tutorials on how to use SimHBA and how to perform behavioral audiometry and other tests on the SimHBA website. Have fun learning.